Hello, everyone, and welcome to today's webinar on accelerating mission-critical applications using AI at the edge. My name is Josh Elliot, and I am one of the co-founders of a software solution called Modzy. At Modzy, we partner with organizations to enable them to deploy, run, and monitor production AI and machine learning workloads across enterprise and edge applications at scale. And today's topic is certainly applicable. Now, I know that the promise of AI, and more recently, generative AI, is probably being thrown at you from all directions. And hopefully that constant bombardment isn't sending you into your own personal AI winter, because this technology, and more specifically, the rapidly growing field of edge AI, is real and can create significant benefits and outcomes for your organization if planned for and adopted the right way. It is my hope that by the end of today's webinar, that you walk away with an understanding of what edge AI is, why it's critical to the defense and national security mission, as well as the things that you need to consider for implementing a successful and secure edge AI solution. Now, before we get into today's topic, there are a couple of housekeeping items I'd like to cover. First, I want to let you know that a recorded version of this webinar will be made available for download in the next couple of days. Please keep an eye out for an email with a link to the recording. Secondly, we'd love to hear from you, whether that's during today's session or after. If you have any questions during the session, please post it using the Q&A function in the Microsoft Teams application, and we'll do our best to address it either during the webinar or at the end. And for those of you just joining us, my name is Josh Elliott, and I welcome you to Modzy's webinar on accelerating mission-critical applications using AI at the edge. In today's session, we'll start by laying some groundwork and context for edge AI. Then we'll get into the intricacies and challenges of building edge-powered AI solutions, like hardware, networking, security, and software components. We're going to talk about some real-world examples and use cases that we're all working on, and provide you a demonstration of how SEMPRE's hardware solution and Modzy's edge AI solution work together. And then finally, we'll wrap up with some Q&A and parting thoughts. So let's jump right in with some quick introductions. I'm joined today by three other very knowledgeable technologists and practitioners. And I'll start with my colleague, Brad Munday. Brad is Modzy's head of machine learning engineer and brings a wealth of experience in data science, machine learning engineering, and building edge AI pipelines and applications. Brad's passionate about helping organizations get outcomes from their AI investments, and he's also a significant contributor and maintainer of Modzy's open source project called Chassis ML. Brad and I are joined by two members from SEMPRE AI. First, CEO and co-founder of SEMPRE AI, Dr. Robert Spalding. Rob is a visionary leader and passionate about using technology to protect and secure our critical infrastructure. As a retired Air Force Brigadier General, Rob also brings a wealth of experience in national security strategy and diplomacy, and had an integral leadership role that led to a reset in a national security and public policy regarding telecommunications in the United States and globally. And rounding us out is John Caudell, or JC, SEMPRE's VP of Systems Architecture. John is responsible for integrating SEMPRE's various technologies into highly available and performance products. He's got significant experience in the infrastructure and technical operations, providing leadership and oversight for the global expansion of cloud-based and on-premise systems across the financial sector. So welcome, team. Let's jump right in. So why is edge AI important today? Well, if you think about it, there are billions of devices that exist in the world, thanks to new technologies, whether that's 5G and IoT, but there's also significant amounts of data that are actually being collected out at the edge. If you believe a Gartner study in 2025, more than 75% of data will be collected at the edge. Today, 90% of that data is unused, and we want to change that. Next slide. When you apply this concept to the mission, the defense and national security missions, you understand the benefits that it could provide. Certainly from a joint awareness and command and control perspective, you would receive improved situational awareness, enhanced decision-making, as well as reduced reliance on human intervention through automation capabilities and increased lethality and survivability. Rob, before we leave this slide and this operational concept here, I was wondering if you could provide your understanding of what capability gaps may exist today with respect to the national defense and security missions.
Yeah, the really major gap here for the military is interoperability. So frequently these networks are bespoke to the platform that they're operating on. For instance, F-35 networks work with other F-35s, but often don't work with the rest of the combat air forces. And so when you're trying to bring a joint force together or a combined force to have them operate together, these communication gaps really make it problematic to fight in the battlefield. Then when you're going to try to bring applications or artificial intelligence to that battlefield, you know, it's not going to be able to run in the cloud. These networks are often constrained on the battlefield. You may have intermittent connectivity. And so when you think about what we have today, it was built for the 20th century. And so getting this 21st century outcome like you're talking about here is extremely difficult with current legacy systems.
I appreciate that, Rob. Thank you very much for that insight. So let's talk about what Edge AI is. It's a term that is, like I said, a rapidly growing discipline. Next slide, Brad. That's focused on deploying machine learning and advanced analytics and AI workloads out to where the data is being collected. Edge can mean different things to different people. It could mean moving a multi-edge cloud out to the base of a tower, 5G tower. It could also mean far edge in the sense of putting a device or a workload on a robotic arm. There are different types of edge, and all of these play a factor in both the defense and national security mission space, as well as the commercial sectors. And it's important to understand the nuance of each of these. Next slide. I think when we're thinking about what is optimal for edge, it depends on the use case. Your system may require ultra low latency. You may have a lot of distributed data that is getting collected, but also needs to get processed and sent somewhere. And understanding what the bandwidth requirements look like for your particular use case. You also have no guarantee of network reliability. There are a lot of situations, especially in the defense sector, where the networks are unstable or unreliable. And that can cause concern because you still need to work and operate in those environments. And then obviously there's a need to process highly sensitive data, and you need to take in consideration the security and privacy of that data being collected out of the edge and the inference results from the workloads being processed. Next slide. One of the things that we think about when we talk about Edge AI and the different types of solutions, that Edge AI solutions that we talked about earlier, is being flexible in terms of how you optimize across the fleets of devices that you may have. Two considerations on the spectrum here that we think about: power, as well as the network connectivity and the types of chipsets that are available. You can see in this graph here, the farther out from the cloud you get, the less reliable the network is and the lower power requirements that may exist for you. These are all considerations that organizations need to take into account when identifying the appropriate use cases for their Edge AI solutions. Next slide. Now, when we think about those different architectures that support those different types of chipsets and those power and network requirements, there are different architecture design patterns that start to formulate. First one is what we call the drone. If you think about a submersible drone platform and think about where the actual workload's going to be performed, being able to develop and train models, for instance, in a cloud environment or on-premise environment, and deploy those models directly to that drone or that edge device, that where the chips and the processing and the power and the compute all exist, that is one design architecture that we're starting to see more and more of. We're also starting to see the factory concept where you have multi-edge nodes available in a connected facility. Consider a manufacturing plant or factory where you have some sort of local data center on the shop floor. And then you also have edge inference servers that are available to conduct the workloads and do the pre and post processing of the data. And then finally, a hybrid edge to cloud computing fabric. I mentioned earlier the idea of 5G tower sites, being able to deploy a multi-edge node cloud to the base of that tower that can serve as a launch point for your machine learning and AI workloads. Each of these designs is valid and true and being deployed across a number of different customers and use cases today. And finding out and figuring out which one makes sense for your particular use cases is important. Next slide. As we think about the different components that are required for successful edge AI implementations, I think it's important for us to look across these 4 dimensions. Clearly, we've mentioned hardware and connectivity considerations. There's security considerations as well. We have to also understand the sensors and the data being collected, because not only is that important for training the models that'll be run out at the edge, but also being able to work with the different sources that are collecting that data. And then importantly, the software piece, the component of it, both in terms of being able to manage this environment that we're talking about here, but also to build the workloads and pipelines into systems that users are aware of and using today, so it's ubiquitous. Rob, would you mind taking us through a couple of these different consideration component areas, specifically starting with hardware connectivity, and tell us a little bit more about SEMPRE and what you guys are up to?
Certainly. Well, especially in hardware and connectivity, there's a lot of different workloads that you might expect, and I think you have to recognize that there needs to be a heterogeneous capability at the edge. So you may have an application, for instance, that's running on FPGA. You may have another application that's running in CPU, and even a third that's running in GPU. So having the ability to have all of those components there locally is very important. Now, typically you see all of these things in a hyperscale cloud, but when we're talking about at the edge, you may not have access to the cloud. For those always on, always available capabilities that are mission critical, you really need that. Now, when you think about the different use cases that you might experience on the battlefield or in a factory, for that always on, always available capability, you need a number of different sizes, performance capabilities, power draw, and that's what the SEMPRE family of devices are. If you think about our world today, we have a number of options for all-inclusive devices. Unfortunately, those devices really don't have the infrastructure to support them on a mission-critical basis. Why? Because a lot of times that infrastructure is not survivable. So not only does it need to have different sizes and power draws, it needs to have the ability to be completely actionable at the location. So if you are experiencing network connectivity issues, you still need that mission to go forward. Imagine, for example, you have a camera for security in your forward operating base, and all of a sudden your connection to the cloud goes down. So now that camera is no longer functioning because the AI application is not accessible to that data. This is when you need to have that capability local, and not only does it need to be local, it needs to be survivable. In terms of bandwidth, you need the ability to have constrained connectivity on the battlefield. You need a mix of both narrowband and broadband capabilities. Sometimes you want a burst capability, to get that data out, but you also want to be able to process AI in place for those things that require a low latency and high reliability. And of course, the other issue, and this is really the problem that SEMPRE tried to solve, is oftentimes in the defense world, we build these systems bespoke. We wanted you to be able to use the devices, the applications that are available in the commercial space today at a commercial cost. So SEMPRE was built for that ability to have those sizes that you needed, the power draws that you needed, but also the ability to onboard commercial software, commercial devices that allow you to function on the battlefield. Next slide. One of the big issues when it comes to hardware is securing the edge. So we talk about zero trust, but oftentimes zero trust only applies to the software environment, but really it needs to be about the entire architecture. So the system has to be tamper resistant. You don't want people being able to get into your hardware, plant bugs, or otherwise be able to exfil data. So they need to be able to, ensure the environment is secure, that it hasn't been touched by outside hands, and that the provenance of both the hardware and the software throughout. You need to be able to have various encryption capabilities, whether that be post-quantum or the latest NSA requirements for instance, classified communications. Physical security is very important just in terms of reliability. So if your system is not resilient against things like small arms fire or EMP, then you can also have a denial of access just by a physical attack. One of the biggest problems that we have today with regard to infrastructure is its highly centralized nature. So being decentralized and having every node be unbreakable itself in terms of being able to take down the network is very important. And then understanding absolutely where every component comes from, what country, to ensure that the overall supply chain security is very, very important. Over to you.
Thanks. Those are all excellent points. I think the hardware and connectivity, as well as the security dimensions of an edge AI solution, are critical. So is the last component, the software component, and why it's important. If you think about all the different use cases, all the different types of devices that may exist that you need to actually push AI workloads out to, having the ability to create almost a continuous delivery, integration and delivery of fleets of devices takes more prep, but it's the best experience for IT and OT systems. And being able to push AI workloads out to those edge locations in a consistent way, understanding the reliability and the performance of those edge environments is also critical. So having a solution that provides you the end-to-end life cycle of a machine learning model, whether it's from the training tools and the data preparation tools, to being able to package that model and deploy it into an enterprise or out to the edge, and then having the central model management capabilities for understanding what devices are being used, what models are being run on those devices, and then being able to manage the configurations of those models out at the edge, I think is critically important. And the last but not least, making sure that you have that retraining loop in place. You're going to continually learn out at the edge from the data that they're processing. And there are ideas and concepts like federated learning that exist where you can share those discoveries with other remote models. And that's a complex system type of environment, but it's important for continuing to improve the performance of the models that you have deployed out to support those defense and security missions. Next slide. Now we come back to this picture, this operational view, this conceptual picture here. Rob, why don't you take a pass at this picture and talk about the different pieces of hardware and how they apply to these different locations, and then I'll do the same for the software side of the house.
Certainly. So what you need to have, no matter the forward operating base, a home side base, or a ship or an aircraft or a vehicle, or a team on the ground, you need to have the capability that's appropriate to the mission. You need to have the ability to be airborne. You need to have the ability to operate in maritime environments. You need the ability to deploy very quickly or pick up and go very quickly. And some of this equipment can be overrun, so it needs to be able to defend itself. And I think the most important thing that you need is the ability to be software definable. So that is the key feature of the world that Modzy deploys on, and being able to push your applications out there to the edge and be able to use it in the way that you want, and to be able to deliver capabilities at the speed of software. Being able to have software-defined radios, network function virtualization, the ability to adjust your networks, to adjust your radios, to adjust the mission that those radios are doing, whether that be radar or communications or signals intelligence. All of that is built into a software definable world where each of these nodes can be whatever you need it to be. It can be a gateway. It can be a processing center for sensor data. It can be all of those at the same time. So this is the real strength of a distributed model where each node is software definable, and the cloud may not be available or likely won't be available.
That's perfect. And one of the benefits of Modzy is that we are able to install in the cloud. We're also able to install on premise, but we're also able, as mentioned before, to install our edge capability in an on-prem edge device location and in a disconnected state as well. Continue operating in that disconnected state. And as you look at this operational concept, the idea of having a catalog of special purpose models that are built for different missions or different MOSs, and the ability to deploy those models or packages of models out to edge locations in a consistent way and a reliable way is critical for being able to improve the decision making and all the benefits that we talked about earlier. Consider the new use cases or additional use cases that may now exist because you're able to push AI workloads out to the edge. Things like the autonomous systems, predictive maintenance, security surveillance, even smart weapons and real-time translation type of capabilities. All of these become available when you're able to push workloads to where they need to be performed and run.
And Josh, I think the point to make here is that the question that we hear from customers with regard to artificial intelligence is what happens when the cloud goes away. And I think being able to tell them, we can continue to operate even when the cloud is not available is very important for these types of missions.
That's exactly right, Rob. That's exactly right. Next slide.
So here's a SEMPRE T in a notional deployed location. This was part of technical experiment 23.3, where we deployed and support SOCOM efforts to demonstrate this technology. There is artificial intelligence running on the camera that's sitting on top of the node there. This provides not only the ability to run AI directly connected to the node, but also on devices that are connected to the 5G network that's shown by the antenna sitting on top of that mast. In addition, there to 5G, the ability to run lower WAN, so low power, long duration sensors, and bring that data into the node where Modzy artificial intelligence applications can be brought to bear. So, for example, say you have that camera collecting photos from motion detection, but then you want to further refine those photos to a certain person or a certain object, then you can do that further as it's brought into the node. Now this is powered by a hardened generator, so this entire setup here has been out to White Sands Missile Range, been tested by DTRA to be EMP hardened, so this is completely survivable in a future conflict scenario with a high-end threat, and it's all connected to satellite for backhaul. The cool thing about that test that we did out at White Sands Missile Range is Starlink was part of that, and it did survive. So this entire setup here is survivable for even the high-end battlefield. I would note the final thing is this thing takes 5 minutes to set up. You don't need an army of engineers. Anybody can do it. I've done it before. You don't have expertise. You basically hook up the cables, you turn on the generator, and your device works. Now, if you need to add applications or you need to add users, all of that's capable to be done there locally or even remotely. And the way that we've designed the remote configuration, both from monitoring and command and control, is through narrowband satellites. So you don't need a big chunk of data to get this thing to do what you want it to do. And in fact, we've made all of that capability on that narrowband channel accessible to providers like Modzy. So if you do have an AI application and it does detect something, then you can use that narrowband connection to get out that alert And then you can come back and say, hey, I want you to send me all the data surrounding that. I want you to run a different algorithm. And it allows you to do that at the time of your choosing in terms of getting out that broadband satellite data via the other network. So really quickly deployed, really easy to use. You don't need to know anything about cellular networks or data centers. Just plug it in and it works. And that's the true, I think, game changer in terms of being able to have AI useful on the battlefield, is to have the infrastructure be as easy to deploy as the technology that you have today.
All right, why don't we jump right into a demo? I think that's next of the capability in action. I just want to remind folks, if they have questions during the session today, please use the Q&A feature, and we'll get to them at the end of the session.
Great. JC, over to you.
Great, thank you, Brad. And now, just as Rob described how easy it is to deploy a SEMPRE node, we'd like to give you a few examples and show you how easy it is to command and control your SEMPRE nodes. So this is an example deployment of SEMPRE Node Manager. And just as easy as it is to command and control via SEMPRE Node Manager, Brad will be demonstrating how the ease of deploying your Modzy models to SEMPRE nodes via the Modzy web frontend. So whether you're locally controlling a node or using SEMPRE Node Manager to control 1,000 nodes, SEMPRE Node Manager is a single pane of glass, which can be used for configuration, monitoring, or provisioning your applications on your nodes, including encrypted communications packages, groupware, or AI applications. It integrates role-based access control and multi-tenancy if needed. SEMPRE nodes can be used as bare metal compute or via orchestration with Docker, virtual machines, Kubernetes clusters, and Rancher RKE2 clusters. And SEMPRE Node Manager integrates with your CI/CD pipelines for deployment of applications. Here, I'd like to demonstrate how easy it is to provision a new cellular device on your SEMPRE node. Let's go down. Here we have your SEMPRE nodes. Let's go to subscribers. Now, if you have not seen these values before, these are what are burned into your SIM card in your cellular phone, which the cellular tower uses to establish the encrypted communications to your cellular device. So let's give this a name, demo device 1. Now these are some default values that are included. We'll choose our network slice here. We're going to add the subscriber. And welcome to Demo World. All right. Well, we're going to go back to subscribers here. The one other point that I wanted to make was, as Rob mentioned, you don't need to know everything about how cell phones work. So in addition to being able to add manually, whether locally or in SEMPRE Node Manager, you can also do something as simple as a CSV file upload, where you have all of your devices already predetermined and it's ready to go. And so that works with both eSIM and eSIM for any cellular devices, 5G network devices, etc. And you can use this to configure whether it's 1 node or 1,000 nodes. Even if one of your nodes is not currently connected to SEMPRE Node Manager for updates, the next time it connects for updates, those updates in the message queue will be sent to your node. And as easy as it is to command and control your SEMPRE nodes, it is just as easy to manage your Modzy AI models, and Brad will demonstrate just that.
Thanks, JC. Let me take over the screen share again. Yeah, and that's a great transition into some of the demos that we prepared to show today, to show how you can run AI models on any set of distributed SEMPRE nodes through the Modzy software. Now, for those who may have joined late, this might be the second time. For those who've been here the whole time, probably the third time you've seen this diagram. And I won't, spend too much time here, but I'd like to re-highlight the what this diagram shows in terms of the breadth of capability that a joint Modzy SEMPRE solution can offer, right? Everything from AI solutions running in your command center and on a SEMPRE F, true data center capability, everything from batch data requests running on, Spark clusters or AI generated reports, just scratches the surface of AI capabilities that you need to run in the data center kind of execution environment. But then as we get out to the field, Rob talked about so many different set of diverse environments, different hardware requirements, connectivity, right? There's a lot of factors. And between Josh and Rob, they outlined why our solutions work really well together. What we'll explore today are, the possibilities for an underwater computer vision system. So we'll kind of double click into this naval expeditionary environment right here. And we'll also explore what a real-time translation dashboard looks like, powered by NLP models, large language models that can be deployed to your tactical ops center, but then sent out to squads to help kind of enhance different missions that you might be working with. So again, just to kind of highlight the breadth, there's a ton of opportunity and capability that we can provide collectively here. So before I jump into the demo, I wanted to set some context for the underwater computer vision system that we'll talk about. Underwater computer vision can be applied to, a large list and collection of applications and use cases, and it's become more popular in the recent years as enhancements and developments to some of the underwater vehicles you might hear of have improved. Some of these underwater vehicles I will mention, ROV, remotely underwater operated vehicle, AUV or UUV, autonomous underwater vehicles, can be sent out from ships to do a whole, collection of applications, whether that be surveying the ocean floor or a nearby bay or area, just to gain a better understanding of objects out there, or marine life, or pollution, right? Certainly some very popular use cases, in addition to things like mine countermeasure, maintenance of underwater structures. The list goes on and on. So when we actually look at that a bit more granularly, what we're talking about are a collection of very fine-tuned computer vision algorithms or object detection models that can detect certain classes. One, aquatic life, fish, sharks, different species. Mines would certainly be one. I mentioned pollution, trash, plastic, bags, nets, things like that. All the way to algorithms that can connect or detect foreign objects, divers, ROVs as an example. I mentioned mines already. Again, I think that the purpose of this slide is to introduce how broad this application is, and there's a lot of different directions we could go. So I've put together, to demonstrate the art of the possible, put together a couple open source models run on some open source video sources, all enabled by Modzy to be running on a SEMPRE node. In this case, would be something like a SEMPRE M device, small device that you could deploy onto one of these underwater vehicles. So let me switch my screen over to Modzy and give you a brief introduction of our platform. So Josh talked about Modzy's capability. In short, in a nutshell, we are the MLOps platform that enables you to centrally manage, deploy, monitor your algorithms, but then most importantly, remotely ship and deploy and serve them out to remote devices. We've now talked kind of at length about what that might look like. So we'll start with our central model library. A lot of advantages here from a data science standpoint. It's a central location to operationalize and manage your models. It's really easy to discover different capabilities. I'll click on the custom category I created for the SEMPRE webinar, joint SEMPRE webinar rather. We'll click on one of these models for a sea life detection capability. We just pulled this model. It's an open source model from RoboFlow. Quickly was able to package and containerize it. And at this point, it's now available via a really easy to use API. So Modzy provides the mechanisms to take a model from whatever state it's in, pre-trained, all the way into a production container that can be sent out to multiple devices. We'll show you an example of that. And again, what makes it great is you can just simply copy paste this code, run it in any number of COTS tools. Rob talked about how important it is to have kind of a software-defined node and ecosystem, meaning you can take any COTS tool alongside Modzy and integrate and create kind of powerful applications at the edge. We'll see what that looks like, or a couple examples rather, in a second. So when it comes time to run your model, you've got a couple options. First, you could simply scale up a processing engine that would run on some underlying node, whether that's on a SEMPRE F or a SEMPRE T, could certainly support Modzy running in this capacity. But what we're more interested in today is how do we take these models and send them out to where the data is being collected. I think what's interesting about what JC showed is how you can connect any collection of 5G devices to a single node, which means that you can capture all sorts of data, and Rob mentioned this as well, whether that's video feeds, LoRaWAN, sensor data, and suddenly, if your algorithm's at that edge device, you can process the data, and there are all sorts of benefits that we've already talked about today for running and processing your AI workloads directly on that device. So when it's time to deploy a model out to a device, you go to our device group page. You can think of a device group as simply a mapping between a single computer vision model and or multiple models to a single device or multiple devices. In this case, when we're talking device, what we're talking about SEMPRE nodes would be the kind of target architecture that we would deploy and run these models on. And the way it works is you'd simply select the models and algorithms you'd like to deploy out to your single device or fleet of devices. For example's sake, in demonstration, we've got a collection of computer vision models, everything from sea life detection to trash, pollution, plastic detection, AUV detection. And then to actually send these models out from your central kind of control plane to those edge devices, you create what's called a secure device token. In doing so, all you need to do is select your target architecture. So Modzy will run anywhere that there's an x86 or ARM chip. SEMPRE nodes certainly have that, and plenty of compute to handle dozens of models, really. And when you generate commands for your target architecture, what will happen is in a few clicks, you can download the Modzy software that will handle all the orchestration, serving, spinning up and down of your model containers on an edge device. And then when you run that, two things will happen. Number one, the models that you defined in this device group will be downloaded to that edge device, and the device will register itself with your control plane. Now, we've talked a lot about the importance of a resilient system to network outages. In this case, this requires a one-time connection, and then all the models are downloaded, and Modzy can run in a completely disconnected offline capacity on those SEMPRE nodes that can do the same. And so some of the information that is returned by the device you can make available here, but importantly, you have that same API that allows you to build applications. I'll show you an example of that in a second. But before I do, in this case, we've listed about 7 models here. JC, I know we've talked about this in the past. How many models do you think you could run on one of these SEMPRE nodes? Choose whichever one you want to talk about. And what are some of the configuration options there available?
Right. Exactly, Brad. So depending on your needs, a SEMPRE node can be configured for heavy AI workloads with FPGA cards or other hardware for AI. The SEMPRE F, B, and T models use commercial off-the-shelf hardware for compute with hundreds of x86 cores, terabytes of RAM, and can include FPGA cards. SEMPRE M is modular-based architecture in which you can tailor the compute to your needs, whether you want to run light GPU-poor AI models, say 20, or configure it with a few models which use FPGAs or other heavier hardware for heavier AI workloads.
Cool. Yeah, thanks, JC. That means that we could basically, increase in this workload by 2, 3, 4, 5 times at least, and have no problem. So the compute power and the resources available on these SEMPRE nodes is really impressive, and it makes our life a lot easier and allows you to kind of create really powerful applications. So talking about applications, I'll pull up a sample, super simple dashboard where you as the user can understand how your models, a collection of different models here, will run on a certain video stream. So again, as I mentioned, we pulled some open source video streams and models. Bear with me as I click things. It takes a second to load. Here's a video feed coming from an ROV. This is something that you may actually may be super relevant. You've got a SEMPRE M running on a UUV and models running in real time to take surveys and scans of the ocean floor. I'll come back to this in a second. Let me click on a different one of a near surface algorithm, and we will, oops, let's see, the near surface view, and we'll turn on the ocean waste detection model. Oops, I have to reload this. So let's see, near surface. Waiting for the video stream to load, and then we'll turn on the ocean waste detection model if this ever comes up.
Yeah, and Brad, I just want to mention, as Rob alluded to, we have the ability to send notifications over a very small link in the 80 byte range, right, for notifications. We use this for sending if something is detected, an anomaly, what you're looking for. We're able to send that back to operators or back to a central command post on a very lightweight message stream.
No, yeah, thanks for that, JC. Meaning that like these predictions are something that you could send for any sort of highly critical or highly confident prediction that could trigger some alert if need be. Kind of if this is running on a system nearby a naval ship or some command center, as JC mentioned. Alternatively, a way that this might work is, I'll click on one more example here as a marine life. You can see a bunch of fish. I don't know why this is continuously doing this. Sorry, guys. Let's see here, marine life. You know, I think the use case certainly is this could be running live if there's a need to do so and there is connectivity. Alternatively, this could be running nonstop, and all the predictions and data made, you know, will persist on the device, so that anytime that device comes back online, we can transfer all that data back to the command center, back to your tactical ops center, and you know, you could take this data due to, you know, this is all created with Modzy APIs or these models running on a SEMPRE node. You can then take that data, aggregate it, and create, you know, pretty extensive analysis dashboard. So if you're interested in that, let us know. We've built more sophisticated demos that take kind of the data return from this demo, aggregate it for some sort of kind of downstream task that's really easy to work with. So this is that first demo, again, talking about an underwater system. Let me go back to the slide real quick to introduce the second demo that we'd like to show. So the second demo was a bit different. We're talking on land now. And what we're going to do is build a real-time dashboard powered by large language models and NLP. We talked, you know, Josh talked a lot about design patterns and how you can really customize both devices, the nodes that you're using, and the models, depending on your use case, depending on whatever mission critical operations are needed. So in this example, in this design pattern, let's say that we've deployed kind of a version of the Modzy software platform that I showed you to a SEMPRE F and perhaps a more permanent tactical ops center. And we're going to focus on the large language models and a specialized set of NLP models that will power this dashboard. So I'm focusing on this dashboard app now. And there really are two concurrent kind of applications of this dashboard. For the first application, let's just follow the dotted lines on the bottom here. And what we'll do, imagine that there's somebody in a squad, a soldier, a warfighter with a tablet that needs to communicate with civilians or needs some other communication where a language barrier exists. Well, what we can do is deploy these models in the dashboard out to a SEMPRE T, and through their 5G enabled connectivity, connect to that tablet device. And so not only can the soldier get that real time, translation capability that I will show, but also we can add, additional intelligence to that. Maybe let's call out certain entities or the most important parts of the conversation, or summarize the translation in a way that's concise and enables the soldiers with that quick time feedback and allows them to make any sort of decisions that they need. So that's kind of one of the applications. In parallel, imagine a copy of this dashboard is also running at your tactical ops center. Through this system of distributed yet connected nodes, we can also send this real-time conversation and translation data back to the copy of this running in your tactical ops center. Pair that with additional data like local social media, local news stations, other kind of audio and or text-based data. And suddenly you have a pretty comprehensive dashboard that allows you to analyze kind of in real time and for broader strategy and whatever might be relevant for the mission. So a lot of application and kind of flexibility here. Now, as I get into the demo, I'll again go back to our device groups, and this time we've created one for your tactical ops center. What we're going to do is deploy 4 natural language processing models to a SEMPRE T node. Something that you could like the node itself, you can manage in your SEMPRE node manager that JC showed, and kind of manage all the devices that that's connected to. And so with Modzy, what you can do is you can deploy the models themselves out to this device. Now, as I mentioned, we've got 4 of these NLP models, and create a dashboard. Now, believe it or not, showing a real-time transcription model is not the easiest thing when the video conferencing tool you're using also requires that same mic. So I went ahead and recorded the first part of this, but then I have the dashboard that we'll interact with just to show you what the translation piece looks like. So I took a very small or short snippet from a Chinese newscast, pre-recorded this so you can see the translation piece. I'll play about 20 seconds of it or so. Not sure if you'll be able to hear the Chinese, but I'll explain this in a second here. But what we see is a transcription, and then at the same time, in parallel, the translation is being happened, right? Anyway, I'll pause this in a second, right here. You get the idea. So this is what would look like in real time if you had this on your own dashboard page. Now, if I pull up the same version of this, right? There's a full translation here. Also pulled these from open source, so I'm not gonna swear by the accuracy of these particular models on that audio, but something that you could certainly fine tune based on the dialect. You can make this a multilingual dashboard very easily. Something that you could support with the SEMPRE hardware. So we've got our translation, and in real time, this might be super valuable to that warfighter. But what you can then do is pair and add kind of additional capabilities to this dashboard. We can classify the sentiment of this. Is it generally positive or negative? If it's somewhere in the middle, you can actually explain predictions. I ran this ahead of time because it takes a bit to run. This is an integration with SHAP. This is a capability that Modzy makes available for model monitoring, both at the edge and in your data center. Drift detection is something else that's available. But again, you can understand kind of why the model is making the predictions it's making. We can classify tokens for named entity recognition. This might be something that you want to run immediately and basically just look to see if a person, organization, place of interest is being mentioned in that conversation. Maybe the word for word translation isn't as important as some of the analytical insights that you could get using some other models. Similarly, we could have a text summarization model create a quick sentence summary for this text. This takes a bit longer, so we'll give it a second. But again, I think that just wanted to demonstrate the art of the possible as it pertains to natural language processing on a dashboard that we run on a tablet, all powered by Modzy, SEMPRE, and the 5G connectivity component there. And we can see a quick little summary. Again, to both help in real time and in parallel, we can be sending this data back to your ops center for deeper, further analysis. Pair this with a large language model for some interactive component if there are any particular questions or use cases that an LLM could aid in. So that concludes the demo portion. And as I go back to the slides, I just want to, we're happy to take any Q&A if there are any. Josh, Rob, JC, any closing remarks before we go into the Q&A session?
No, I appreciate it. I thought the demos that you and JC did were superb and really showcased the power of being able to work in an offline edge or remote location, and I think could provide significant benefit to organizations and groups within our national defense and security mission space. With that, we do have one question in the chat. I think this is probably best answered offline, but Rob, one of our guests asked a question about the specifications of the SEMPRE T node versus the SEMPRE N node. I don't know if you have any data sheets that we can make available after this webinar today, but any thoughts on that, or at least top line type of comments you'd like to make? You're on mute, Rob.
Yeah, just really briefly, in terms of connectivity, they're essentially equivalent. In terms of the compute ability, there you have over 1,000 cores in the SEMPRE and almost 300 cores, CPU cores in the SEMPRE. And these are the latest Ice Lake processors. But you also have the ability to do FPGA, and FPGA really works well for AI applications and provides up from anywhere from 100 to 1,000 times the capability of a CPU when running an AI algorithm. So a lot of capability in both, but that's kind of the general high-level view, and we're happy to provide capability sheets to anybody who wants.
Thanks, Rob. And while you have the mic, here's another question for you. Where do you see the biggest opportunity for customers to take advantage of this type of joint solution? Is there a specific mission set or use case that comes to mind?
Well, one of the big ones we're seeing today is just the ability to have a deployed solution that allows you to use the latest applications and the latest devices. So having, just setting up a tactical operations center somewhere in a location to do that quickly, and then to be able to employ, AI, through Modzy's models, very quickly to set up your perimeter, to have the devices to enable control of those sensors, plus also drones and other things. That's really one of the big ones we're seeing today.
That's awesome. And Brad, maybe you can share some thoughts on this topic or this question. For organizations that are just getting started building out, and maybe JC, you can weigh in on this too, but building out their edge AI solutions, what would you say are the most important first steps that they should take?
Yeah, it's a great question, Josh. I think one thing is to really understand the data sources you have and what the end outcome is. So in other words, like the middle ground would be the AI model itself. That's a kind of really important first step. And then the second is when you're designing and building the solutions themselves, the applications, the dashboard I showed, right? A couple of those examples, you need a way to reliably and consistently integrate AI models. I showed a combination of about a dozen models today. When I was prepping for this, they come from 6 or 7 different Python frameworks that require different dependencies and different Python versions. And so just to kind of build that out of the box is difficult, number one, but also not super reliable in a production application. So having something like a standard unified API to consistently integrate these results as you're doing your development makes it really easy. Longer term when that app does make it to production. And so I think that's just a couple thoughts on starting points and what's important to think about.
How about you, JC? Maybe from an architectural perspective, anything that you'd like to add?
Yeah, I think Bradley was right on. Whenever you have to have the ability to quickly change your model, because if you're not sure what exactly your sensor is going to be, like for instance, the angle of a camera or the audio that's coming in, there may be a lot of background noise. So having the ability to switch that quickly is important. And then from an architectural standpoint, having the end-to-end capability for updates, and also for if you need to know real time, if you hit some sort of notification threshold, that real-time ability for updates is critical if that's your use case.
Yeah, and I will say something about dependencies there, Josh. And one of the things we've seen with application providers, once they come to the SEMPRE node, is they're so used to pulling libraries from the cloud and different capabilities. And when they try to deploy it at the edge, it breaks. And so you have to really deploy at the edge and have that in a standalone configuration to know that your application is actually going to work out there in the wild. And so we have sometimes we get lazy and deploy things in the cloud and expect, that thing's going to transition quickly. No, you have to basically really get out of that kind of cloud mindset and really understand that the resources that you need have to be on that node if you're going to be operating in a combat scenario.
I think everything the three of you said is spot on. I think when you design for an edge use case, it makes operating in a cloud or on premise that much easier. And when you understand the model complexities, the deployment complexities, even the integration complexities of being able to use the inference results that you're getting out of the AI workloads. Moving on to security, just here's a question for you guys as well. Maybe Rob and JC, you can take a stab at this. What are the most significant security considerations in a sensitive defense environment that people really need to pay attention to?
One of the approaches that we took as a company was to not just look at software. We looked at the entire thing, and not just the technology, but also the personnel. And so to do that, we embraced what's called surety. This is typically found in the nuclear world for handling nuclear weapons, and it applies to the personnel, the material, and the procedures by which you operate the equipment. So we at SEMPRE have basically taken a comprehensive approach to security, not just the supply chain, not just the software, but everything, even the people that operate on it, even to include, if needed in the SEMPRE Node Manager, the requirement for two-person control on any kind of software update or any kind of configuration change, to include, any type of, hardware change. Having that ability to understand that, everybody that's had access to the capability, whether it be hardware or software, and then what was their status at the time, and the ability to have two people that are knowledgeable at the task and can see somebody else working. This doesn't have to be for everything or every customer, but certainly the customers that want security need that comprehensive look at it. JC, anything to add to that?
You're right on, Rob. And on the encryption side, on the SEMPRE nodes, up and down, from the disk to the memory to the network in and out, all the communications are encrypted, all the data is encrypted. And if something bad happens to the node, somebody tries to exfil data, it gets wiped.
That's excellent. Well, we're coming up on time here. I want to thank you all for participating today, and to our guests that joined us for the webinar. Thank you. If you do have questions, please feel free to send them to us after. If you're interested in learning more about the joint SEMPRE Modzy solution, please get in touch with us. Our information is on this screen. We'd be happy to answer any questions you have and go through a discovery conversation with you. And then last but not least, I think both SEMPRE and Modzy believe edge is the future of operations, whether that's in a defense or national security context or even a commercial context. And we are building for that solution space. If you have ideas, thoughts, questions, please let us know. Rob, JC, Brad, thank you very much for your time today. And thank you, everyone. We'll be in touch. Bye.